Hey guys, welcome back from Christmas break. I know it's time to get back to work, so we're not going to waste any time. We're going to go ahead and jump into chapter 6. But before we do, I wanted to give you a little bit of review and go over some terms. So I'm actually right now going to teach from page 354. So just be sure and take notes from this section. You don't really even have to open up your books for this. Just get out your notes with your note paper that you have. This is Monday night, and hopefully, unless we have snow this week, and follow along. Now, the first term I want to go over is ordered pair. An ordered pair is an x and y value that satisfies an equation. In other words, we can solve the equation and it works out to be correct. So let's take a look at an example. Here we have, for number 1, 8x minus 5y equals negative 2. Now, if you'll notice, I replaced in 6 for the x value and 10 for the y value. And then when we multiply 8 times 6, we get 48. And then negative 5 times 10 is negative 50. And 48 minus 50 equals negative 2. So we see here that when the x value is in fact 6 and the y value is 10, then it does satisfy our equation. Therefore, we would say that 6 and 10 is an ordered pair that satisfies the equation 8x minus 5y equals negative 2. So an x and y value is an x and a y value that both satisfy an expression or an equation. Okay, now the next one is we're going to look at equivalent equations. Basically, that's all equivalent equations are. It's two equations that work out to be the same. And equations, anything that has an equal sign in it. Okay, so that's simple. All right, so here we have two equations, 7x minus 4 equals 10 and x equals 3. Are these two equations equivalent, and if not, why? Well, of course, in order to know if they're equivalent, I'm going to have to get the x by itself, just like it's by itself here. So we're going to accomplish that by adding 4 to both sides. So now we have 7x equals 14. And then, of course, we know we go on to solve that by dividing both sides by 7. And we see here that x equals 2. Well, we see here that no, they are not equivalent equations. Now, had this come out to be 7x equals 21, and we divided both sides by 7, then we would have gotten x equals 3. And yes, they would have been equivalent equations in that case. But they're not. Now, the last term I want to go over with you is absolute value equations. Remember, absolute value just simply expresses the distance on a number line. So it's always a positive value. And we always use these two little bars to represent absolute value. So the absolute value of A equals A. The absolute value of negative A equals positive A. Hence, the absolute value of negative 3 equals positive 3, because absolute value is always a distance. Remember, we never say the distance from my house to the mall is negative 10 miles. We would always say the distance from my house to the mall is 10 miles, or the distance from the mall to my house is 10 miles. We always represent distance in positive values. Okay? So I hope that helps. All right. Thanks.